guys, let's take a look at the distance formula and midpoint formulas. First thing I'd like you to do is plot these points like it says. A is negative 3, 2, so that'd be right about there. We're going to label it capital A. B is 4, 6, so 4, 1, 2, 3, 4, 5, 6. And then C is 4, 2. Okay. So we want to find the distance from A to B. This is what they're asking us to find, how long that length is. Now if they wanted us to find the distance from, say, A to C, we could do that. We could just say, okay, 1, 2, 3, 4, 5, 6, that's 7 units across. If they wanted us to find the distance from C to B, we could do that also. That's 4 units up and down. But to find the distance from A to B, we can't do that because it's diagonal. So we have a couple of options. The first one that should probably come to mind is, notice what we have. We have a right triangle. So we can use our favorite theorem, Pythagorean theorem. So let's go ahead and do that. Let's find out what the length of AB would be. So our formula is A squared plus B squared equals C squared. Now don't get confused. Even though we have capital A, capital B, capital C, those are identifying our endpoints. The little a would be like here, little b is going to be this leg, and little c is going to be the hypotenuse. So it's important to use the little letters. There's a difference between little letters, identifying the sides, and the capital letters that identify the vertices. Okay, we don't know c squared. So 7 squared is 49, plus 16 equals c squared. We're going to add these two together. I get c squared is equal to the square root. C squared is equal to 65. I take the square root of both sides, so that cancels. C is equal to, if I round that, it doesn't say in this case, but I'm going to round it to the nearest hundredth. And I get, let me see. Okay, 8.06. So I can now say that length is 8.06. It makes sense. 4, 7, 8.06. We're good. So one way of finding the distance of a line that's diagonal is to go ahead, if they were to give you like this point and this point, and they wanted you to find that distance, you could go ahead and make the right angle, and from there the right triangle. But what happens if I were to give you points like this? Maybe 101, comma, negative 3, and negative 5, or negative 5, comma, 43. Something like that. I mean, I'm totally making them up. 101, negative 3 would be all the way out here. Negative 5, 43 would be all the way up here. Excuse me, if you were to make a graph of this, your graph paper would be huge. You would be taping pieces of graph paper together. Only just to get the dimensions of your legs, not even to do the problem, just to get those dimensions, so then you could actually find the hypotenuse. So that wouldn't be the best method in that case. So lucky for us, they came up with another formula known as the distance formula, and it makes sense. It's the distance from any point A to B, and even if you're going across, it measures the distance between any 2 points. Okay, so here's what we're going to do. Let's draw in 2 points and actually make them connect like that. Okay, this is going to be x1, y1, x1, y1 to represent our first ordered pair. This is going to be x2, y2 to represent our second ordered pair. Alright, so let me show you the formula. It's a long one, it's a big one. I will give it to you on tests or quizzes, but want to make sure when you're doing homework you write it down correctly. It's the square root of x2 minus x1, that's in parentheses squared, plus parentheses y2 minus y1, close parentheses squared. So that's all you have to know. D equals square root of x2 minus x1 squared plus y2 minus y1 squared. It looks long, it looks complicated, but it's actually very easy. Okay, so let's try it once, and then I'm going to come back and show you something special about it. Find the distance between the points M, 6, 3, and N, 5, 7. So we can first go ahead and label this x1, y1, and then x2, y2. Let's do that right off the bat. Oh, y2. x1, y1, x2, y2. Now we can go into our formula, and I'm going to put like the skeleton. I like putting in like the bones of the formula, and now I can substitute in all my numbers. Okay, so inside here I'm going to say x2 minus x1. x2 is 5, x1 is 6. So I'm going to scratch them out because I've already used them. Then I have y2 minus y1. y2 is 7, y1 is 3. So I'm going to scratch those out. So I've used them all. That I can honestly promise you is the hardest part and what most people mess up if they get the problem wrong, because from here it's just order of operations. But if you substitute the numbers into the wrong place, it's not going to work. Okay? So I'm going to go ahead and do what's underneath parentheses first, because we said whatever's under that radical sign follows the order of operations. Negative 1 squared. Remember, negative 1 squared is really the same as negative 1 times negative 1. If you put it in your calculator as negative 1 squared, the calculator is going to think, to itself, negative 1, it's going to square the 1's, but it keeps that negative only out front. So it's going to give you negative 1, which is the wrong answer. Instead, it should be negative 1, so you should put this in parentheses. You should be able to do that in your head. You don't need a calculator, but just so you know. Negative 1 times negative 1 is positive 1 because the negatives cancel out. So negative 1 squared is 1. 4 squared is 16. Our answer, square root of 17. Now they didn't specify if they want that left in this form, if they want it in simplest form, or rounded. They don't tell us, so we could leave it as that, or we could round it to 4.12. Either one. Okay? So that's the application of the bin point formula. Not too bad, but that's where it comes from. So let's try another one. Go to the next page. There's 3 more we want to look at. Okay, so the first thing I'm going to do is label x1, y1. There we go. x1, y1, x2, y2. Please, please, please do that. You're less likely to make a mistake. Alright, now I have my parentheses set. I'm ready to fill things in. The regular formula I'll put over here. It's x2 minus x1 squared plus y2 minus y1 squared. So inside the first set of parentheses is x2 minus x1, 7 minus 11. Scratch them out. Inside the second set of parentheses is negative 5 minus negative 2. Negative 5 minus negative 2. I'll squeeze it in. Okay, y2 minus y1. So whenever I go to do the next step, let's simplify what's in parentheses. I get negative 4. And here we have negative 5 minus negative 2. That's really plus a positive. This is negative 5 plus 2, which is negative 3. Negative 4 squared, like we saw on the other side, is negative 4 times negative 4, or positive 16. And negative 3 squared is negative 3 times negative 3, so it's positive 9, because a negative times a negative is a positive. I add them, I get the square root of 25, and that is a perfect square, so my distance is 5. And that's it. Okay, let's try another one. I'll switch my color. It's going to get a little jumbled because there's a lot going on. Yeah, we'll just put it in here. Okay, so actually, I'll do this one out here. Letter B, the negative 1, 3, and then 5, negative 2. So I'm going to go ahead and label x1, y1, x2, y2. Put them in the formula. I'm going to set up like the bones of the formula, so I just fill things in from here. First thing, we have x2 minus x1. x2 is 5 minus x1, which is negative 1. So those are out. Then I have y2 minus y1, negative 2 minus 3. Now I take it to the next step. Negative 5 minus, or 5 minus negative 1 is really plus the positive. I get 6 squared. Negative 2 minus 3 is really negative 2 plus negative 3, so negative 5 squared. 6 squared is 36. Negative 5 squared is 25. I add them both together. I get 61. I can leave it. Again, the directions here just say find the distance, so you can either leave it as the square root of 61 because that is in simplest form, or you can round it by putting it in your calculator and you get 7.81 rounded to the nearest hundredth. Hopefully by now it's starting to click a little more. There's a lot to this formula, but it's not really hard. It's just making sure you put everything in the right place and remember your basic, algebra skills. All right, x1, y1, x2, y2. Put in, oh, I cut right into it. Put in the bones of the problem, the formula, x parentheses squared, and now let's start filling things in. So x2 minus x1 is going to be 10 minus 0. y2 minus y1, that's a negative 5. I almost crossed it out. Negative 5 minus negative 1. Okay, so then I go to the next step. Inside my parentheses here, 10 minus 0 is 10. Negative 5 minus negative 1 is negative 5 plus 1, which is negative 4. Next, I simplified the next step. 10 squared is 100, negative 4 squared is 16, so I get, in this teeny little space, square root of 116. Again, if I go ahead, I can leave it or simplify it, or I can put it in my calculator, and the square root of 116 is 10.77. Okay? Nice job on those ones, guys. Let's try one with a word problem, and we'll keep going. Example 2 says, on a gridded map, Clive's hometown is shown at the point 517. His cousin's hometown is shown at the point 1014. The straight road connects the two towns. If one unit on a map represents 10 kilometers, how far apart are these two towns? So he wants to know exactly how far apart he is from his cousin's hometown. So my points are this, 517 and 1014. Now it doesn't matter which you call x1 and x2. Like let's say I would have put them in a different order. I would have put 1014 then 517. That does not matter at all. You can call, I could have called this one x1, y1, this one x2, y2. It still works out to be the same thing as long as you keep them x, y, x, y. And obviously substitute them incorrectly. Okay, so let's go ahead, basing it off the original formula. Inside my parentheses, for the first set is going to be my x's, so it's going to be 10 minus 5. Those cancel out. Inside my second set of parentheses are going to be the y's, so 14 minus 17. Okay, now I'm going to go ahead and simplify. 10 minus 5 is 5 squared. 14 minus 17 is negative 3 squared, out of space. Up here, I'll continue it. 5 squared is 25, negative 3 squared is 9. 25 plus 9 is actually 34. And the square root of 34 is 5.83. Oops, not a square root anymore. Square root of 34 is equal to 5.83. Now they wanted us to figure out what this distance would be, knowing that 1 unit on a map represents 10 kilometers. So this equals 1 unit, but 1 unit on a map represents 10 kilometers. So really we're going to multiply that by 10 and we get 58.3 kilometers. That's how far apart they are. Now let's go back for 1 second